be talking about the Newton's law of motion. Today is a perfect day to talk about that, because when it starts to snow and the roads get icy, you will start to understand how objects are affected by Newton's law of motion. Some will argue that the greatest scientist of time is this guy, Sir Isaac Newton. He was clearly a genius. He summarized half of his decade of work in the Principia, which some will argue as the greatest book ever written. He also explained gravity and how universal gravitation worked. Then he quantified the movement of the planets and summarized the work of Kepler. You are maybe familiar with the story that somehow an apple fell out of the tree and hit it on the head. That's probably not a true story, but he definitely referred that in some of his work. And so let's go through Newton's law of motion. First law. He sometimes referred to as the law of inertia. He read this way: everybody remains in a state of rest or uniform motion unless by an external balancing force. And that never changed. And so let me give an example. So let me take a cup and let go of the cup. And that's the Newton's first law of motion.
Let's go to the second law of motion. This is probably the most important because it's the base of the modern physics. So what is it? The acceleration of an object is directly proportional to the force acting on it and inversely proportional to its mass. So what does it mean? Well, the best way to understand and remember the second law of motion is the next equation. Force is equal to mass point acceleration.
So let's make a mass like that. And now let me apply a force from this side. As a result, I can make that weight accelerate. Now let's make a new weight that is bigger, and we apply the same force. It doesn't accelerate as quickly because the mass is bigger.
The second way is that if I have bigger mass and I apply the same force to it, I'm going to get a slower acceleration. So that's the summary of the second law of motion.
Now we are going to talk about the third law of Newton. The third law of Newton said that for every action there is an equal and opposite reaction. When two objects interact, there is a pair of forces on the interaction objects. The direction of the forces on the first object is opposite to the direction of the force of the second object. Newton used the third law to derive the law of conservation of momentum from a deeper perspective. However, conservation of momentum is the more fundamental idea.
Now we are going to show you an example about the third law of Newton. If we have, for example, two balls and we apply a force in one of the balls and we make them to collide, the result is going to be that the balls are going to leave in the opposite way.
These are the three Newton's laws about motion, and we hope to see you again.